Welcome everyone to the visual component testing session. My name is Nikolay Advolodkin. I'm a senior solutions architect here at Sauce Labs. All that fancy title means is that I have a huge passion for testing. Started out back in 2008 as a manual tester, then transitioned to test automation, used some of my programming background with a tool called QTP back in the day. It's actually still around, I think, called UFT. But I transitioned away from it, got into Selenium and started doing a bunch of other test automation. And now I work with customers all over the globe, helping everybody to improve their test automation, whether it's unit testing, integration testing, acceptance testing, and so on and so forth, just making everybody as efficient as possible using the knowledge that I've gathered over the years. But most importantly, the thing that gives me the most credibility here is that I'm an animal lover, so don't forget that as you watch my presentation. So I'd like to start off by having you watch a video and just following the instructions that are on the video.
This is the shell game. I'm going to hide this Hershey's Kiss under this cup. And the object is for you to pay attention and follow along and try to guess which cup the Hershey's Kiss is under at the end. Try to guess if it's in the left cup, the middle cup, or the right cup. Let's check the left cup. The middle cup. If you guess the middle cup, you got it right. So now we're gonna make it a little more complicated. I've added an extra pair of hands and I've added additional colors here. But that's only to distract you from the pink cups. One of the pink cups will always have the Hershey Kiss underneath. So let's get started. So can you guess where the Hershey Kiss is?
So the point of me showing that little game was that human eyes can deceive us and they can miss critical information. So obviously we're all here to talk about visual testing. And so let's apply some of these ideas of how we can miss visual errors and actually see them in real life. So it's really interesting because in 2020, right, we all had the COVID pandemic, and I no longer really need to show this slide of how impactful the good quality digital experience is on a business, because pretty much the entire world experienced it firsthand. If you weren't ready, to be a digital company in 2020, you probably felt it extremely painfully when you had to transition to the world. And if you were ready, you probably got many more advantages, such as companies like Amazon and Zoom that were booming during the pandemic. So here's a really interesting real life story. Go ahead and quickly take a look, read about it. I actually wasn't aware of it until I started preparing for this presentation, but I'll let you all read through it really quickly. Basically, what had happened here was Stanislav Petrov was monitoring nuclear missile launches in the former Soviet Union. And what had happened was that his system started to display that the United States was launching missiles at the Soviet Union. And so this was a visual display. And luckily, Petrov was able to analyze the information and figure out that the visual displays being queued on the system were not valid. Yeah, exactly like war games. So thanks to him, it's a call that may have averted a nuclear holocaust. So luckily, today, we don't have such world-ending issues, I hope not at least, that we're dealing with on a daily basis. However, there are companies being impacted every single day by visual bugs. So here you can see actually on a Southwest airline website, there's a visual bug where the continue button to check out was actually blocked by this text. And Southwest brings in something like $3 million an hour from their website. And so they obviously, even if this bug was up for a long time, for a short period of time, it could have cost them millions of dollars. Here is another website. This is actually an old iteration of my website, which unfortunately does not bring in millions of dollars an hour, but it also had bugs. I actually tested my website when I created it on a standard large screen 1920 by 1080 resolution because that's what I have, but I never checked it on other smaller resolutions, and only to realize that when the screen becomes smaller and my responsive website actually starts to kind of merge together like this, there are these issues that happen. And of course, I didn't lose millions of dollars, but it is still potentially hurting my reputation as a quality assurance expert, not doing a good enough job at quality assurance myself. So how do we prevent such bugs? Well, probably as you all have guessed, the reason that we're here is with visual testing capabilities. And I am specifically here to talk to you all about visual component testing. You all have already seen our offerings for visual end-to-end testing, and visual component testing is a little bit different, and I'm going to cover that here. So probably you all already know what visual testing is. You have seen presentations from everybody. You have seen presentations about how to do it well. And it's basically ensuring that your application appears as you want it to appear to the end user, right? That, for example, the Southwest website looks how you want it to look, and the button is not covered by text, costing the companies millions of dollars. Making sure that whatever component you want of your application is actually in the right place and not causing potentially harmful situations for your customers. So that's why we have SOS Visual Component Testing. SOS Visual Component Testing is a solution that is added to your Storybook tests, and it allows you to do automated visual testing of all of your components, storybook tests, without actually writing any automated tests. So if you already have storybook tests ready, Screener Visual Component Testing can automatically take all of those stories and run them through our visual AI algorithm, and then help you to find potential issues in your application. And of course, if you're familiar with Storybook, you know that it works really well with front-end design systems such as React, Vue, and Angular. So the benefits of visual component testing are that you can test every component automatically. So kind of as I've already said, if you have storybook tests present or you want to start doing component-driven design, you can automatically get visual testing of those components as well without having to write any extra code. You can catch visual and functional regressions just as visual end-to-end testing. Visual component testing can do exactly the same thing, except visual component testing is more focused on the components instead of an entire page layout. You can test UIs across browsers and resolutions, and you can integrate into a team branching workflow. So how do we get started with visual component testing? So you need to make sure that Storybook is installed. You need to make sure that you've written some Storybook stories, and of course that you can run Storybook on your server. So here's an example of a Storybook story that is not people are not familiar with. Probably if you're a front-end dev, you probably are familiar with Storybook, as it tends to be an extremely popular way to test components. But if you're not, you can definitely get started. And there's a really great tutorial on Storybook website on how to get started. The second part is to install Screener Storybook. Simple npm command to install Screener Storybook. Then you create a Screener config. You can follow our project wizard to help you get that set up. This is what a config looks like. I'll show you all some code as well after this, but it's pretty simple. You're just kind of specifying a few details in terms of what you want to test. And then with this configuration file, you'll be able to run your Screener component testing against all of your Storybook tests. Yeah, and that's the final step, is just running your Storybook tests. You can create a script if you want, or you can just do npm run commands directly. Cool. Let's actually demo this thing and show you all what I'm talking about. So over here, you can see I'm actually in the Screener UI. This is where all of the visual tests go. Again, I'm sure you all have seen it multiple times throughout these presentations. However, here you can see I recently ran a bunch of Screener components through our solution, and you can see we've ran 254 different components in 1 minute and 49 seconds. Which is, I think, pretty good and pretty fast. It's a really good feedback into your dev cycle, right? We always want extremely fast feedback from our continuous integration cycle, and so that's pretty fast. We can come here and take a look at exactly what happened. We can see that 4 components have changed and 250 components have been previously accepted. You can see how the components are classified. They get names. They can even be, they're classified by components, and each component gets different states. If a component's changed, they get flagged as changed, and you can see those here. We can take a look at a few of them just to get a better idea. So on the left-hand side, you can see a previously accepted component, and on the right-hand side, you can see the current iteration of this component. Down here, you see in orange, we have a highlight that tells us exactly what has changed with this component. In this case, we can see that our regenerate API key button has moved from the right-hand side to the left-hand side. And so now it's up to us to decide whether this is something that we want in our application, or is this an accidental error. We can even dig in further to see root cause analysis of this issue. By taking a look here, you can see that we have, with this component, we have had both a layout change and a style change. We can see which, come here and see what happened. So you can see, for example, that the style has changed, that we've got a new style called right, which previously wasn't there. Sorry, the right style was deleted, and so our component shifted left. And so we can decide what we want to do here. We can ignore this change from here, right? And so saying that this is totally okay, we intended for this button to move left. Or if it's a bug, we can, of course, go ahead and fix it and then rerun these tests. Let's take a look at a few more components. Same thing. Here's another component that has also changed. You can see, again, in this case, we've changed the color on this button. and looks like this text has changed here. Again, we can open up the view and we can see we have had a style change. So the style change tells us that the color of our button has changed, right? It went from a previous color to a different color. In this case, of course, from a clear to a blue. And we can even see a content change, right? We see that we used to have a 1, and now in the place of a 1, we now have a 2. So the red means it was removed, and the 2 means that it was added. And again, we can decide how we want to tackle these changes here. And another really cool thing to point out here is in this case, you can see that we actually had an entire component removed. That's why it's highlighted in red. Red means a component was removed. Green means it was added. Orange means that it was changed changed all over in both iterations. And so here you can see that this component was removed. But what's interesting is that Screener actually doesn't flag the entire component here on the right-hand side, right? It only flags this, which means that it's smart enough to know that even though a component was removed, all of this was shifted up, but it doesn't flag this because you can see this is exactly the same. And that's what we call the hybrid diff, a hybrid diff which does both a visual and DOM changes. And so thanks to the smart hybrid diff, it doesn't flag this as many other tools would, saying that the entire page would have changed. And of course, we can take a look here to see what has happened. And we can see that there was a structural change. There are 4 types of changes that can be detected by Screener. And this component here was deleted. Let me show you all some quick code as well. So here's a solution. You can see that we have a bunch of our different components here. Every single component has a corresponding Screener story. Right, you can take a look at those Screener stories here. And in order to be able to test all of those components through Screener component testing, all we need is that Screener config file that I showed you all here. And then just by configuring it and pointing it at the appropriate storybook configuration directory, you'll be able to run your tests and have Screener automatically validate all of the components. Cool. So just to kind of summarize a few little points here, Screener component testing comes with the following customizations. You can do structure, layout, style, and content modes, which are all of the changes that can be detected, which I showed you all. You can use root cause analysis to figure out exactly what went wrong. And you can actually even ignore different kinds of changes. I showed you through the Screener UI, but we can also do it through code as well. We can write we can ignore by category and by selector inside of our code, so we don't have to manually do that on the UI. We can also even do interaction testing of components as well. What you all saw was a bunch of components that don't have state. But there are some components that do have state in our applications. And so whenever we do have such components, we can test those stateful components using our Screener Steps API. It allows us to actually navigate through an application and invoke different kinds of events on your application so that you can capture a snapshot of your application in a certain state and make sure that everything looks as you want it to look. The other really cool feature that is here to help developers is pull request validation. You can integrate Screener into any CI tool, but one of the most popular ones, of course, is GitHub. And you can integrate it into GitHub and then get feedback from GitHub about the status of your Screener component tests. And of course, that obviously allows us to reduce behavioral changes. It allows us to catch bugs earlier, right? On every single commit or pull request, we can get those validations and make sure that nothing going to production is getting negatively impacted, such as my website or the Southwest website that we've seen previously. All right, cool. So that is pretty much it. On this slide, I have some demo source code that I've linked to here. And now I open it up to some questions.
Awesome. Thanks, Nikolay, for sharing that intro to component testing. So how do you automate to verify on multiple screen sizes?
Oh, that's a really fantastic question. So it's actually pretty simple with both SOS Visual End-to-End and visual component testing as well. I will actually just show you all the documentation for that. So the documentation for Screener is here. If you go to component docs and then here check cross browser, it's actually just a matter of adding these browsers to your config. So you can see you can just add a bunch of browsers to your config, or if you want to do across multiple device resolutions, you can do it in this manner, right? You can say device iPhone 6 or device iPhone 10 or whatever, and then putting those in there. And then when you have that, each of your components will actually run automatically across each of those resolutions. And I believe I even have an example of that here. Yeah, you can see an example of that here where I ran some code against an iPhone X, a Galaxy S8, and an iPhone, two iPhone 10s. And then when we look at that here, you can see how they look in the UI. It's different components being displayed in those different resolutions. So it's actually super simple.
Nice, nice. Yeah, I can see that, different iPhone resolutions. So how does this make it easier to maintain?
How does the cross-browser make it easier to maintain?
Or sorry, how does like cross-browser or with visual testing specifically
Make the tests easier to maintain?
Yep.
Yeah, so I actually have been lucky enough at my previous employer, we did visual testing and it was extremely successful. We had a really nice application that was well suited for visual testing. And I find that visual tests are drastically easier to maintain than, let's say, functional tests, because instead of focusing, on an entire page and trying to find different kinds of elements, trying to interact with those elements, having synchronization issues, with visual component tests, for example, you see how easy it is to actually set up. Is if you're already doing component-driven design and you have storybook stories in place, it's just a matter of installing the NPM package and also adding the config file. And then once you have that, your test will automatically run, and most of the time they will work pretty successfully. You might need to do a few tweaks. Now, with end-to-end testing, visual end-to-end testing, it's a little bit harder because you have to render the entire page. And so sometimes there we get into tricky situations where maybe there is like lazy loading, or there are components that you have to scroll over in order for them to come to life or render in a certain state that you expect. And so there it becomes a little bit harder than component testing, for example, but it's still easier than functional testing because we just have a lot less code to worry about and a lot less things such as synchronization and element locators to worry about for our maintenance purposes.
I got a question come in. So on the first test run for each resolutions, does it automatically set that as the initial baseline?
Oh, that's a fantastic question. So it does not. So you can see here in this example, it does not automatically set that as an initial baseline. And why that is the case, it's because there is no way for any visual testing tool, not only Screener, but any visual testing tool, to know what is acceptable to you, right? So for example, with this component here, is this an acceptable way for our component to look? I don't know. This is only something that the developer or the UX engineer can decide. And so at this point, if this looks as you want it to look, at that point, you accept it as a baseline and set it as a baseline. And then from this point forward, these components will be used as the baseline to check against. But of course, if you look here and everything looks as you want it, you can automatically just click the accept all selected button and it'll accept all the components that are here. But yeah, usually with any visual testing tool, there is an initial stage of manually making sure that you set the baselines, because like I said, it's hard to know. No system can know what is acceptable for your requirements or not. One way to mitigate a lot of that, actually at my previous employer, where we were running between 3,000 to 9,000 visual validations every 2 weeks. So in order to minimize the amount of visual validations that we were doing, you have to make sure that you don't visually validate every single page that may or may not be important. There are some pages that are more important, other pages that are less important. With visual component testing, it's drastically easier because they'll just automatically all be checked. But if you're doing like end-to-end, you can kind of prioritize what you're visually validating and then kind of scale up from there.
Question came in. Can you show how to do interactions tests using Screener?
Oh yeah, good question as well. Let me just show you all the docs here. Yeah, I wish I had enough time. I was actually looking to add the code to my solution that I created for you all, but hopefully after this I'll have some more time and I'll add it to the source code that I was showing you all. Let's see here.
It's the third one. Testing.
Oh yeah, perfect. Thank you. Yeah, there you go. So here's how to do interaction testing with your components. So there's different ways for React, Vue, or Angular. But here's, for example, you would just wrap it in a component, and then you can start doing operations like clicking, capturing snapshots, and so on and so forth. And if you want to, here's a full steps API of what you can do in your tests.
Who would you say is responsible for defining the components? Like, is it the UI designer, the front-end developer?
Oh, that's really interesting. So I think it's a combination, right? Because the UI designer and the developer, I'm guessing, are working together to define how the components look, right? If we're talking about component-driven development, for example, that's a kind of a organizational level thing where everyone decides these are the components, this is how they're going to look, and we're going to reuse them all over the organization or all over the team, right? So whoever those individuals are that are in charge of making sure that there are standards for your team or organization, those are the individuals that'll be in charge of coding the components and then also setting the baselines for them in Screener.
How sensitive is Screener on visual changes? And can they adjust those settings?
So I covered the 4 types of visual changes that Screener can detect. Layout, man, I'm forgetting them now.
Layout, structure, content, style.
There you go. Layout, structure, content, and style. So those are all the ones that it will detect. In terms of adjusting the sensitivity, I'm not sure what you mean by that, because I guess what else really is there to adjust that pretty much covers the gamut of the entire HTML.
So there's a question on the DOM verifications. Are you able to compare the page source for each tag, attribution, and content inside, or do you have some exclusions? Like, for example, if the app has dynamic IDs, will this be a problem? If the app has custom theming, such as different color setups?
In terms of dynamic IDs, if you're talking about for component testing, that's not going to matter, because I'm guessing you're making a link potentially to something like Selenium or WebDriver. That's not going to matter because we're not really focused on the locators of visual tests. That's why one of the benefits of visual testing is you typically just either open up your page or render your components, and then you just capture snapshots. It has little to do with locators. When locators are useful is, for example, if you are doing Actions API, that's when a locator may come in handy. So in that case, your dynamic IDs may hinder you, but that I don't see that scenario happening too frequently.
There was a question that came in earlier when you were going through the visual review process of the different colors. For the warnings, errors, failures, the color schemes, how we have red, green, and orange, are you able to configure those different colors inside of the UI?
Oh, that's a great question. That I think no. That would be probably a feature request for our product manager, Hussein. But as of right now, these are the colors that you get is the orange, the green, and the red for components being highlighted in terms of what happened.
Yep. I would agree. Those are our ticks right now.
Yeah, but yeah, I'm sure Hussein can take that into consideration. We're open to any feature requests now, I'm sure.
Some other questions. So what are some best practices that you can share with the audience here? Are there any real life examples or benefits from visual testing versus just automated testing?
Yeah, great question. So kind of as I hinted at before, in terms of some best practices that I've actually had from my previous job where we did a lot of visual testing, prioritize your components or your pages, right? Depending on what, again, we have to always think about Screener, Sauce Labs and Sauce Labs Visual offers two types of testing. The one that I just showed is screener component testing, which is more focused on components and more of a developer friendly flow, versus visual end-to-end testing, which renders an entire page and plugs into frameworks like WebDriver and Selenium, right? So whichever one you're doing, you can, if you're doing visual end-to-end testing, prioritize your pages to make sure that you don't need to automate everything off the bat. Capture the most important ones, right? For example, for Southwest, it would have been very wise for them to do visual end-to-end testing on their checkout flow, right? I don't know how many pages that is. I'm guessing like 5 for a user to book a ticket and check out. Had they had a few tests in place, they would have avoided millions of dollars of costs, right? For the nuclear missile scenario, had they just made sure that, you know, that the page is loading the correct amount of missiles on there, that would have been significant. So you can prioritize that and then scale out as you need. Some other stuff to think about is for visual end-to-end, one thing that we see many customers have challenges with is if they have dynamic CSS or UI components, for example, like lazy loading or components that only come to life when you scroll over them. Those are a bit more challenging. And so don't forget to scroll to the bottom of your page so that your entire page is rendered before capturing the snapshot. Probably another most common bug that I've seen is with responsive websites. Because as kind of I showed on my blog website that I wrote, you can make sure that your website looks on good on one resolution, but that doesn't mean that it's going to look good on other resolutions. So when you have a few pages to check, put it on some of the most popular browser desktop resolutions and mobile resolutions as well. Don't forget that mobile traffic accounts for at least 50% of all traffic. So put it on both and make sure that those pages look good on all of those resolutions, especially for the responsive ones.
There was a question that came in, like, how do you compare Sauce Visual with Selenium?
They're not an apples to apples comparison, because Selenium is a functional browser testing tool, right? So Selenium is all about making sure that a functional flow works. Can a user log into my application and buy a Southwest ticket, for example? And visual testing is all about making sure how your application looks as you want it to look for the user. And so again, those examples that I showed before, for example, Selenium can go in and click on buttons and log in, but that doesn't mean that the buttons are in the right place, that the fields are in the right place. So for example, with Selenium, you can click the Southwest checkout button if you're using a JavaScript click, right? But actually a real user tapping on the screen or clicking with a mouse would not be able to click on that. And so a visual end-to-end test or a visual component test would have caught that bug, while a Selenium test, depending how you're clicking on that button, would not have caught the bug, because Selenium is only worried about executing. So remember that. One thing that visual testing can actually help with is a lot of individuals tend to open up a page and make sure that a page will have the most critical links or the most critical buttons on it by basically just doing a bunch of element locators and checking that those elements are present on a page. With visual testing, you just do that with a single check, right? You open up the page, just check it, get your snapshot, and that's it. It's a single line of code. So it can help in those kinds of instances as well.
So for those that are testing on native mobile apps, any advice you have for those who are focused on native mobile app testing and want to integrate a better visual test method other than manual testing for native mobile apps?
Yeah, that's a super awesome question. I personally don't know of any solution offering visual testing on mobile, which I think is extremely unfortunate because mobile is probably, especially with web, is probably having the most amount of issues there, right? Because most of us look and design our websites on laptops, right? Who's doing development on their mobile phone. And we a lot of times will forget about mobile and to check how websites actually render. So I unfortunately don't know of any solutions or best practices for that, but I do know that Screener is working on a mobile solution, and I believe that it's coming by the end of this year. And Hussein can always correct me if I'm wrong.
And then I guess oh, another one came in. What are the capabilities of using Screener to verify animations like loading indicators?
If you needed to create an animation, to enable an animation, for example, you can either use the interactions API to enable an animation, right? Maybe you need to click a button and that button will then enable an animation. So you can do it like that and monitor that animation. Keep in mind, it depends on the animation, right? Because things that involve time or loading are pretty difficult to visually test, because let's say you have like a little spinner, right? When you capture baseline, that spinner may be in one place, and then when you capture it again, it might be in a different place. So those kinds of things are harder to visually validate. I don't even know if I would recommend validating the spinner. What you might just be curious in is doing like a component test and making sure that the start state and the end state of your spinner looks as exactly how you want it to look. And then that's how you could validate it.
All right, I think I got two more questions for you. How does Screener handle the unexpected pop-ups or notification?
Oh, that's an interesting question. So unexpected pop-ups. So there's nothing native built into Screener to tackle that, because again, we kind of have to think of it from a generic perspective, right? Like some customer may have a website that doesn't have pop-ups or notifications, another customer may. So it's really hard for any tool to know what is the expected behavior of the application. Maybe your application should have a pop-up, or maybe it shouldn't. It's impossible for the tools to know unless we configure that somewhere up front in like a configuration file or something. So it would be on the end user's side, which is you guys, to figure out how to handle that. So you can, let's say it's a page, you open up your page, you use the interactions API to get rid of the modal if you're not interested in it, or if you want to keep it, there's nothing for you to do. And then once you get rid of the modal, you can take the screenshot. And so that's how you would handle it.
Got one more for you, Nikolay. So what's the biggest challenge that you see for visual testing?
I think the biggest challenge that we've seen with customers, and actually myself when I'm trying to visually validate my own website, is dynamic content, especially when you're trying to render an entire page, or like usually nowadays we have a long page, right, that a lot of it will lazy load as we scroll over it. There might be some animations. So a lot of that tends to trip us up when we're doing automated testing with visual, because it's important to scroll to the end of the website to make sure that all of the components load, and make sure that any other dynamic content that pops into place is also there. And for example, if there is content that, like, let's say, for example, my website has pop-up boxes that are meant to capture your email address, right? So we probably don't want those in a screenshot. So it's really all about making sure that your application is in a good, stable state before capturing the snapshot. And so I think that's where we all tend to have the most challenges of getting it into that stable state. And that's actually one really good way to combat all of that is visual component testing, because then you just make sure that all of your components look as they're supposed to look. And so then you kind of know that, oh, by the way, my, for example, account settings, right? There's nothing going to be wrong with my account settings because this is how it looks. And so you may not even need to open up this account settings, click on the user profile, render the entire page in order to check it, because you can see the component here itself.
Got one more that came in just now, if you don't mind taking
No,
another.
I don't mind. I appreciate all the questions, guys. You all are asking some fantastic questions.
Since there are so many resolutions and screen sizes and browser scalings, would you suggest for dynamic content to test bucket resolutions like small mobile sizes, medium HD resolutions, and large ultra HD resolutions?
So to me, this question sounds like almost how do you prioritize so many different screens and screen resolutions and browsers, right? So I personally just like to look at some of the most popular ones. So of course it depends on your business, but why not try to capture the 20% of the resolutions that probably entail 80% of the world, right? I mean, for example, iPhone, you have to have an iPhone resolution on there, but iPhone luckily doesn't have so many resolutions that are the most popular. And so that's already a majority part of traffic. Capture a couple of the most popular Samsung devices, Android devices, capture a couple of the most popular browser resolutions, and now you basically can have a majority of the population, again, depending on your needs. That's how I would do it for my website. My boss, actually, he worked for Retail Me Not, where it was really cool. They had an exact breakdown by browser and like resolution of how much money each browser and resolution earned them. So they knew exactly, for example, how to prioritize their visual test, because let's say IE8 earned them, I don't know, $1,000 a day, while the latest Chrome earned them $1 million a day. Why waste your time automating IE8 when you can, capture the majority of the problems in the most impactful areas? So I hope that answers your question. That's how I would do it. I would just have you, and the other way to do it too is, of course, you can take the most important pages and put them on more resolutions if that's more important to you, and less important pages, you can just have them run on one resolution, just because you want to make sure that those less important pages are rendering and looking correct, which is good. But then the most important pages, you can make sure that they're looking good on the most popular devices and resolutions.